So that was step one in our journey from Shplait to a more machine level of code, where we weaned our interpreter away from using symbols at runtime. Instead, we just have numbers representing positions in the environment. Step two is another step that we've already done before, where we got away from relying on Shplait's implementation of continuations by changing our interp to interp plus continue and representing continuations explicitly. There's not really much change when we change to doing that with xpd. So here is our interpreter with compile step to xpd, but we still have an interp function that uses recursive calls, and it takes the results of those recursive calls and nests it inside of other expressions. So again, relying on Shplait's implementation of continuations. Here is that interpreter converted to still use xpd, but also use our own continuation data type, with the usual done k plus second k, do plus k, and so on. And so our interp now is split into interp and continue. We have an @d case, which uses listget instead of lookup, but overall the transformation to interp plus continue as before. And recall that the point here is that interp may call and continue or interp again, and continue may call interp or continue, but they do so only in tail position. So we're not relying on Shplait's implementation of continuations to implement Mo's continuations. We are still relying on Shplait's implementation of function calls, though, in the sense that when we call interp, we provide it 3 arguments, and those get passed along and bound as local variables in the body of interp. So our next step is to move beyond that and switch to a more machine level notion of registers in goto. That is, instead of having a call to interp that's like this, where we pass it 3 arguments, we're going to jump to interp by calling it with 0 arguments. Before we jump to interp, we pass the arguments along by storing them in some global variables. I'll call these global variables registers because they're meant to represent registers at the machine level. So where interp used to have an exp argument, we're going to have an expreg register, and we put L into that register before we jump to interp. Similarly, when we build up this plus second k, which was delivered as the k argument before, we will build that same record but put it into the k register. In general, we would also set the environment register to the argument that we want for this interp call, but here, this interp call is using the environment register, so we would just be setting it to itself and we can leave it up. We can take a look at that implementation. Here I've got exp and xpd and continuations as before, but I've changed interp so that instead of taking an exp record and doing a match on that exp argument, I have this global variable that's the expression record. It starts out with just a 0 in it, but normally that should be set before jumping to interp. We match on that register where we have the different kinds of expressions as before, but in, say, plus d, instead of calling interp with 3 arguments, we set those registers just as we saw on the slides. Meanwhile, in continue, its arguments are represented by kreg and vreg, so continue does a match on kreg, and whenever it wants to call interp, it has to set the other 3 registers, or when it wants to call itself, it has to set that k register and v register as well. When we get to the end of a program with this interpreter, we just return the value that's in the value register. Our tests are mostly the same as before, but now we have to parse and compile, and we use this helper function interp x. Interp x takes those arguments, just like interp would, but then runs this more machine level interp by setting the registers and then jumping to interp. If we look again at interp and continue, we see that there are still some things that look like function calls, like this do plus k here. This is a variant constructor, so really this is allocation, and taking care of allocation is going to be our next step.